Welcome to GATE 2021 Model questions on control systems. Today's our topic is Routh Hurwitz criterion. Let us see the question number 1. A control system is being shown in the figure and asking to select an alpha that meets the closed loop system to be stable and the steady state error for unit step input to be less than or equal to 0.05. So that is the control system shown and options. Let us go to the solution. But you have to meet the two requirements, in which one is steady state error for unit step input to be less than or equal to 0.005. So the steady state error for unit step input, we need to be less than or equal to 0.05, and we need the closed loop system to be stable. And we have to select the value of alpha to meet these two conditions. Let us go for the steady state error calculation for unit step input. What is the mathematical formula to find the steady state error for unit step input is 1 by 1 plus Kp, where Kp is limit s tends to 0 g of s. But whenever you substitute s is equal to 0 in this open loop transfer function, we'll get alpha by 1 minus alpha. Hence, the steady state error for unit step input is 1 by 1 plus what is the Kp is alpha by 1 minus alpha, which this value will be 1 minus alpha. And it should be less than or equal to 0.05, means from here you'll get alpha should be greater than or equal to 1.05. And if you select any value of alpha greater than or equal to 1.05, then we can meet the steady state error for unit step input less than or equal to 0.05. Not only steady state error, we want the closed loop system to be stable also. For that, we'll go for the Routh-Hurwitz criterion method. Let us find the characteristic equation. What is the characteristic equation is 1 plus g of s equal to 0, which will get it as 2 plus alpha into x cube, 1 plus alpha into s square, plus alpha minus 1 into s, 1 minus alpha plus s plus alpha equal to 0. If you simplify this characteristic equation, we'll get it as like this. Alpha minus 1 into s plus s will give only alpha s. 1 minus alpha plus alpha will give only 1. According to RH criterion, for a third order system to be stable, if you compare this third order CATS equation with our standard model known as x cube plus bs square plus cs plus d equal to 0, according to RH criterion, for closed loop system stability, BC should be greater than AD. Whenever BC is greater than AD, then the closed loop system will be stable. Let us apply this condition for the third order CATS equation. You'll get 1 plus alpha into alpha should be greater than 2 plus alpha. For alpha square plus alpha greater than 2 plus alpha, alpha cancels, you'll get alpha square greater than 2 or alpha greater than root 2 or 1.414. So this is the value of alpha for closed loop system to be stable. Okay. If you select the alpha value greater than 1.414, only closed loop system will be stable. And what is the value of alpha? We have to select it to meet the steady state error less than or equal to 0.05 is greater than or equal to 1.05. From both the condition, which value of alpha if we select it, we can meet the closed loop system stable as well as the steady state error less than or equal to 0.05 is obviously alpha should be greater than 1.414. If you see your options, which option is there which is greater than 1.414 is only your option D, if you can see it. Only option D is greater than 1.414, that is given as 1.5. But if you select alpha value 1.5, definitely the closed loop system will be stable, as well as we can meet the steady state error less than 0.05. Thank you.